Hello everyone, I'm back with another video about programming with MIDI. This is a follow-up to a previous video where I was telling you how to set up Python RT MIDI on a computer and how you could send messages, MIDI messages from your computer to a device like a synthesizer. This is a follow-up in response to a viewer question from Stephen. He asked if I could do a follow-up video where on your device, you're listening to MIDI messages from a synthesizer or a sampler or whatever. So this is what this video is going to do, and it uses a lot of the same core concepts. Again, I'm going to go into IPython here. I'm on a different computer here. I'm on my my Linux machine, but this is exactly the same. It works. It should work very similar as long as you have the prerequisites installed. I'm on Python 3.10, and we're going to start off by importing RT MIDI, and then we're going to set up the connection to listen for input devices. So we need the sort of handler for that to start with, which is this class, which is similar to the MIDI out class we use, but it's called MIDI in, right? And we're going to instantiate this, and this will handle all of the connections. And if we go MIDI in dot get ports, I think the function's called, we can see again here all of the MIDI in devices that we can listen to. So we've got this list. It's got 4 devices in it. We've got this is the 0th thing, 0, 1, 2, 3, because indexes for lists start at 0 in Python. We're going to use the OPZ again in order to look at this. So let's make a connection to that. So MIDI in dot open port, yep, that's it there. And we're going to say device 3 because this is 0, 1, 2, 3 again, right? So the OPZ is the 3th thing in the list. And we can check to make sure that we definitely have a connection here. Is port opened? This function will tell us if the port is opened. That's great. That's all connected and working. It should be able to receive MIDI messages. Now, on this handler here, this MIDI in handler, we've got this function get message, right? And that's what we're going to use to retrieve the MIDI messages. And how it works is there's a queue that's your whatever's handling MIDI on your system, whether that's Jack or ALSA if you're on Linux, or it's the sort of Windows equivalent on the Windows machine, it's listening for MIDI messages and putting them into that queue. And this thing is capturing that, right? Storing up this queue. And you can use get message to retrieve, pop a message off that queue. So it's adding them on the end, right? And you can use get message to take them off the top. So it's like first in, first out. It will keep on adding them in, and then you can take them off the other side. So we can use get message to do that, and it can return either the MIDI message or nothing, because if nothing's been added to the queue, there's nothing there, then it'll just give you nothing back. So we're going to do that. Actually, before I do that, I'm going to import time because we don't want this. Well, I'll explain why in a second. So while true, so this is a while loop. This will just go round and round. It will keep on doing the contents of this loop over and over and over again. And what we want to do is retrieve the message and DT, we're going to call this, and I'll explain that in a little second. And if we call it, go to MIDI in and then get message. Here we go. And then we want to check to see if it does have a message, right? If the message is there. If it's none, we don't want to do anything. So we want to check to definitely make sure that there is a message. And if there is a message, we want to for now, we're just going to print it off. I'm going to show you some more interesting things you can do with it in a second. And then else, if it doesn't have a message, then we're going to sleep for a little bit. So I'm going to sleep for a millisecond. And this is just so it doesn't just completely hammer your CPU, right, over and over and over again, because the while loop will just go round and round and round and round. So here we go, it's waiting now, and you can't see anything. You can't tell that anything's going on. But I pressed a button on my, hopefully you can hear that. I pressed a button on my OPZ, and you can see that it's responded here. So this is this is a MIDI message. Like I showed you before, it's an array of integers, or usually we represent them with hex, and I'll show you how to do that in a little second. We've got the MIDI message, and then afterwards we've got this DT that I mentioned, which is the change in time since the last MIDI message was sent. So if I do this again, now there's been a big gap since the last one was sent. You can see that, there we go, there's 28 seconds since that last one was set. And that enables you to get the sort of the relative spacing between the messages and reconstruct exactly what you've heard. Okay, so that's how you do it, and it'll just wait and listen here. You can modify a parameter like this and it will behave similarly. Now, what happens if we want to do something a bit more interesting? What if we want to kind of make this more readable, for example? Well, I've made a little script here, and I'll add this as a gist on GitHub, and I'll share it in the description so you can go and look at this and extend it and whatnot. I'm just going to open it up in Vim, and so here we've imported our dependencies. Time and RT-MIDI, not very much required here. And as I've just shown you in IPython, you instantiate it. I've opened a port 3 because, again, I know this is my OPZ, how it's connected at the moment. There's smarter ways to do that, like I showed you in the other video, to make sure you get the device you're expecting. And then while true, so we're doing a while loop again, we're getting the message, and then we check to see if there's a message there. We're unpacking it here, so all this is doing is taking that tuple that comes out of that and splitting up the message and the change in time. And then we convert the message, the first byte of the message, right, the first number, we're converting that to a hexadecimal string using this function, this Python function here. And then we're going to do some string formatting where we put the command first, and then the rest of the numbers that are associated with the MIDI message, and then the change in time. And I'm going to add this short sleep again. So let's run that. And then see what happens. And again, it's just sitting waiting, right? And you can see, there we go, it's sending it. Now you can see much more clearly what's going on here, right? I'm on the lead channel on the OPZ, which is this channel 6. You can see that this nibble here corresponds to the channel number. Now it starts at 0, so 1 is 0. So if I go to the drum track, you can see here that it's 0 there. So that's channel equivalent to channel 1. Right, that's just how it starts. It goes up from 0 to 15. Well, 0 to F. F is 15. And then this first number here is the MIDI command. And again, I discussed this sort of in detail in the previous video, and I'll link that at the end. But yeah, you can see that what's going on. And for example here, and this is the payload again, MIDI note and a velocity here, and the change in time. And if I press stop, so I press stop, you can see there's a whole bunch of stuff that's sent here, and it ends with this, FC. FC is the message that's for stop. It's the MIDI stop message, and it has no data associated with it, right? Like it's just stop, there's nothing else to say. I can change a parameter, and you'll see it goes all the way up to 127, and then all the way down to 0. And you know, this is telling you that it's CC change, so this is controller change, sorry, and it's on channel 0 to start with. So yeah, you know, that's the how you would do it. Now you can build much more complexity up on top of here. Listening for this, maybe you're waiting for a particular note in and you want to harmonize with it, right? So you can detect that, then you could figure out what the, you know, maybe up a major third or something, and then play in harmony with whatever you're playing in. Totally possible with it. You could connect that up to another synth and then send a MIDI message out. All sorts of weird and wonderful things that you could do with this, which is really cool. If you are interested in doing something like that, I would suggest this library here. Hopefully you can see it nice and clearly. MIDO. This is another Python library, and it's a kind of higher level library than RT-MIDI. RT-MIDI is very, you know, you're quite close to the actual representation, the binary representation of the MIDI message. And this is a nice wrapper for sort of making MIDI messages and processing them. So I'd recommend that if you're wanting to do more complex things, unless you have a good reason why you would, you know, you're wanting to use RT-MIDI in particular, then MIDO is a really nice alternative. And I think actually it's built on top of RT-MIDI. So yeah, let me know what you think about that. If you have any questions, please ask them in the comments. If you'd like me to do a follow-up on any other aspect of programming with MIDI, if I'm capable of answering it, because you know, I'm an enthusiastic amateur, if I'm capable of answering your questions, then I will. And if there's a video you think would be useful or interesting on this topic, then please let me know. I'm happy to follow up. So thanks and goodbye.